All right, today we're going to look at assignment 36, which is moment of inertia, and we're going to start with problem 17. So it says determine the moment of inertia of the system shown above. So there's three different objects, but we're considering those to be point masses, so the shape of the object doesn't matter. So those aren't necessarily like a sphere or a hollow sphere, anything like that. Now it says the dark dot and the rods holding the masses together have negligible mass. So that dot is the axis of rotation and the rods don't matter. Now why is this important? Well, we might be doing other problems where the rods themselves could be again like a thin rod, and then that would have a moment of inertia. So this dot is the axis of rotation, and here's our three masses. So this is 3 kilograms, this is 1 meter, this is 1.5 meters, this is 4 kilograms, and then this is 2 kilograms, and this is 1 meter. So the moment of inertia of the system is basically the summation of mr squared. So it's this mass times this distance to that axis of rotation squared, plus this mass times this distance of axis rotation squared, plus this mass times this distance of rotation squared. So I is equal to m1r1 squared plus m2r2 squared plus m3r3 squared. So now when I calculate the moment of inertia, it's 3 kilograms times 1 meter squared plus 2 kilograms times 1 meter squared. So again, 3 times 1 squared, 2 times 1 squared, plus 4 times 1.5 squared. So when I add all this up, I get 3 plus 2 plus 9. So my moment of inertia of the system of three objects is 14 kilogram meter squared. And that's it for number 17. Okay, now we're going to look at number 19. So 19 is a little bit different because now they're actually telling us certain shapes, which we need to use the equations for the moment of inertia that we know for those shapes. But first I'll draw the picture. So I have a disc. Then from the disc I have a rod. And then from the rod I have a sphere. So this is a disc, this is a rod, and this is a sphere. So they give us a lot of information, so I'm going to write it down, because I want to make sure that I don't mix anything up. So because they're telling us these shapes, I'm going to have to look up on my chart, what's the moment of inertia of a disc? What's the moment of inertia of a rod? Okay. So it says, determine the moment of inertia of the system shown above. The disc has a mass of 6 kilograms and a radius of 3.6. So the mass of the disc is equal to 6 kilograms, and the radius of the disc is equal to 3.6 meters. Now I would look in my notes or my book or something else and say, well, what is the moment of inertia of a disc? For a disc, the moment of inertia, I, is 1/2 mr squared. So that's for a disc. Then it says the rod has a mass of 4 kilograms, so the mass of the rod is 4 kilograms, and the length of the rod is 7.2 meters. So the length of the rod is 7.2 meters. Now, this is the axis of rotation. This is the rod. This is very important because the moment of inertia for the rod is going to be different depending upon where the axis of rotation is. Is it in the center? Is it 1/3? In this point, it's on the end. So I would look on my chart and I would say, what is the moment of inertia for a rod on its end? Okay, so the moment of inertia for the rod on its end is 1/3 ml squared. And this is for a rod at the end. So this is extremely important. And then I'm going to continue reading the problem, and it says the sphere. So now the mass of the sphere is 2 kilograms, And they tell you that the radius doesn't matter. So what does that mean? So what that means is, if you look at this, usually we measure stuff from center of mass to center of mass. This rod, they're telling you, it says specifically that it has a negligible radius. So because this little radius here is negligible, what that means is, I think I put too many, what that means is that I'm not going to actually use the equation for a sphere. I'm going to count this as a point mass and just use the equation for a point mass. So for this one, I'm just going to say I is equal to mr squared. And again, this radius is not the radius of the square. This radius is actually the distance to the axis of rotation. Does that make sense? There's different ways you can do this. I think when you do things separately, you're less likely to make a mistake. So when I want to find the moment of inertia of this system, the summation of I is going to be I of the disk plus I of the rod plus I of the sphere. But what I would do, instead of doing it in one giant thing, I would calculate them all separately. So I would first start with the disk and say I of the disk is equal to 1/2 mr squared. So it's 1/2 the mass, which is 6, times the radius, which is, and again, this is my axis in the middle, 3.6 meters squared. So the moment of inertia of the disk is 38.88. Now I'll do the rod. So the moment of inertia of the rod, remember it's at an end, so for the rod I'm doing 1/3 ml squared. Now remember, here's the rod, so it's going to be 1/3, 4 kilograms, times 7.2 meters squared. So when you do the math on the math, this comes out to be 69.12 kilogram per meter squared. And then the last thing we're going to do is we're going to do the moment of inertia of the sphere. So we're taking the sphere as a point mass. We're not taking into consideration a sphere because, again, the radius of the actual sphere is negligible. So that's just mr squared. So it's 2 kilograms. Now remember, from the sphere to here is the length of the rod. So that's going to be my distance to the axis of rotation. So that's going to be 7.2 meters squared. So this comes out to be 103.68. So then my total, I just go down here and add it all up. So my total moment of inertia is going to be the disk, which is going to be 38.88. Plus 69.12 plus 103.68, and when I add it all up, my moment of inertia of the system is 211.68 kilogram per meter squared, which we can round to 212. So again, if you do it step by step, it makes it a little bit easier. When you take shortcuts and try and do it all in one line, you're more likely to make a mistake. And again, this is why we write down our given and find. We have 3 different objects here. They have 3 different moment of inertias. The more you write down on paper, the less likely you are to make a mistake.